So today we're refreshing your memory of relations, functions, and linear functions, quadratics, and then we'll do the other functions other days, okay? So first off, let's start. What is a relation? Who remembers? X and Y together make an ordered pair, but you just can't have one ordered pair. You usually have several, right? Like on a function, you have several ordered pairs that together, those infinitely many ordered pairs make some type of relation, okay? So a relation is a set of ordered pairs, a set of ordered pairs. You always start with the relation first before you go to the next thing, which is on the next slide, because when you have a set of ordered pairs, these ordered pairs could potentially make up a function, okay? If it's not a function, then it's just a standard relation, but it's a set of ordered pairs that when you plot them, they create some type of, well, they create a relation, okay? They have to follow a certain rule in order to be a function. Maybe we'll have better luck on this one, but what is a function?
Function is like it's the equation part of it. So like.
But not every equation is a function.
Oh yes.
Isn't it like when there's one output for every input or input for every output, something like that?
Something like that. Which
Yeah.
one is it? Which one is it?
No, because it has to follow the test.
It has to follow a test. Yep. Yes, it's one input for every output, okay? In other words, one X value cannot have multiple Y values because like you said, it has to pass a vertical line test in order for it to be a function. So what I've written on the board, would that be a function? Yes, it would be, okay? Because we have every X value has a different, or sorry, every X value is different. And so it corresponds to a Y value. Now you can very much have a relation like this. Would this be a function?
Yes.
Yes, it would be, because again, we have one input for every output. And if you were to plot those points, every single one of those points passes the vertical line test. Okay, so one input for every output. This is important. Why? Because you may be presented with something like this where you're asked to define, is this a function, yes or no? This is one of those that you actually do on the pair deck. Is this a function? All right, majority of you guys said that no, this was not a function. Okay, when we take a look at this, remember, for it to be a function, you cannot have the same X value and different Y values. So here you have two several times for your X's with these different Y values. If you were to draw a quick sketch of that, you would have 2, -1, 2, 0, 2, 3. All of these lie on the same vertical line, which you cannot have in order for it to be a function. So this one is not a function. This one is not a function. What about this one? Is this one a function? Very good. This one is a function. This one is a function. Someone tell me, why is this one a function? It passes the vertical line test, so no matter wherever you draw a vertical line, it is only crossing your function one time, each time. Very good. Is this one a function? You're responding on the pair deck. This one is not a function. Why is it not a function? Where? These two right here, okay? They did not pass the vertical line test here. Now, had one of these been an open circle, then this one would have been a function, just like how it is here. Okay, this one is still good. This vertical line is still good here, but this one is what made it not a function. Very good. Last one. Function, yes or no? This one here is an example of a rational function. We are still looking at whether or not this passes the vertical line test or not, okay? What is happening as x gets closer to 0? What's happening on that red part of the curve? It's not going to hit that asymptote. Where's the asymptote located? It's located at 0. More specifically, x is equal to 0. Remember, they do exist, asymptotes, vertical as well as horizontal. What's happening on this side, on the pink side of the graph?
Start from like the number that's not touching the vertical asymptote, and then to x.
And on both sides of this vertical asymptote, you say it's not touching, but it's getting what?
Close.
Very close, which means it's going to continue to get closer, which means it's never going to like be ever vertical. And so because of this, this one is a function because again, at any point in time, even as it's approaching the asymptote, it only hits a vertical line one time. So this one, yes, it was a function. This one was a function. Questions on functions. What makes a function? So vertical line test, when you're looking at a graph, when you're looking at a set of ordered pairs, whether they're actually like a set or maybe even in a table, your x's do not repeat. So on your pair deck, I want you to write down all the words that you know of that are associated with the domain. All the words that you know of that are associated with the domain. Okay? Here's one particular one. We have X values. I think that was kind of consistent across the board. A lot of you guys said X values, okay? Do you realize that domain could be written in either set notation or interval notation? The one thing that you want to be very careful of when you start adding in words is like words like range, or even words like minimum value or maximum value. Do realize that you're more so associating that with not the X values, but the Y values. Even putting X value with it, minimum and maximum are associated with Y values, not necessarily X values. Here's another really good one. Input and independent values. Yes, input, what you put in, usually you plug in a value for X, and that, yes, that is your input, that is your independent values that is associated with your domain. I think everything else was pretty much across the board, okay? Oh, I like this one right here, union. When would you use a union? When there's an asymptote in your graph, essentially when there's a break in your domain, which is your X values. How far left, how far right is the graph defined? Very nice, very nice. Of course, if we do domain, then we do range. All right, let's see, Y values. One of those that was very consistent across the board, okay? Very consistent across the board, okay? It is your dependent variable, okay? Because think about it, Y's cannot exist without X's, okay? So if it asks you what's your dependent variable, then you know you're talking about your Y's, it's talking about your range. Maximum, minimum, as I talked about before, that's associated with the Y value. Like when you think about a quadratic, that highest point, that lowest point is associated with the Y's. Here's another good one, output. Output was another good one that you guys, some of you guys had said. And then of course, when you are finding your range, I just had it. When you are finding your range, you have your lowest values to your highest values, because we're talking about the Y-axis. We are talking about the Y-axis. Now with domain, with range, just like with domain, it can be written in set builder or interval notation, okay? And so revisiting set builder and interval notation, Remember, interval notation was the one that had the brackets. When were those used? That's when it was less than or equal to, greater than or equal to. Or in other words, when the value was included. So of course, when you saw parentheses, infinity was definitely with parentheses, or essentially when the value was what? Not included. This was also used when you had an asymptote. Okay, we also used union with interval notation, infinities with interval notation. Okay, but in set notation, we didn't use infinity. We didn't use union. Instead, in set, remember that's with the curly brackets. We would use X for which values? The domain. We would use Y with the range. This is actually where we use the inequalities to represent particular values. And if we had multiple pieces in our domain or range, we use commas to separate them. We did not use unions. Unions are with interval notation. Commas are with set notation. Infinity is with interval notation. The inequalities are with set notation. And just to make sure I don't confuse anybody, let's clear that out there. Okay? These were the differences. Remember this notation, the curly bracket, you would say the set of X values such that whatever. This is also where we included the not equals to. So let's say we had an asymptote. It was all real numbers except for that asymptote. We would say X does not equal the asymptote, or Y does not equal the asymptote. That's when we use set notation. IB uses set, always. Now you yourself, you don't have to necessarily use set notation if you yourself have to provide an interval or the domain yourself. But do realize that IB is going to use this notation. You need to understand what that notation means. Questions? So then let's have a look. I want you to find the domain and the range of this particular function. I want you to find the domain in interval, and I want you to find the range in set. You're doing this on the Pear Deck. So again, just to be sure, you guys, infinities go with interval notation. Inequalities go with set. You cannot have infinities in set notation. You cannot have inequalities in interval notation. You cannot have curly brackets in interval notation. You cannot have square brackets in set notation. Each thing has its own notation, okay? So with that being said, here's a good one, okay? The domain is written in interval notation. The range is written in set notation. If you are looking at the board, you should see it. First off, since that coordinate is -1, 3, you know the furthest left it goes is -1. The highest it goes is 3. So the range is everything from -1 all the way until infinity because of the arrow. We have a square bracket around -1 because it is included, hence the closed circle. And infinity always has a parentheses around it. For the range, since 3 is the highest it goes and it's everything that's less than 3, less than or equal to 3, this is exactly how you would write it in set notation. You do not include infinity with set notation because technically, if you look at old school number line, this is essentially what you're representing. Negative infinity is all the way over here. So you represent that with Y is less than or equal to 3. Questions on this one? Because you have 3 more.
No.
No.
Okay. So then let's take a look at this one. I want you to write both in interval notation. Then the next one's going to be both in set. Everybody look at the board. Interval notation has parentheses or square brackets. When you are trying to write out the domain in interval notation, you have to think, what is the furthest left this graph goes to what is the furthest right this graph goes. So when you take a look at this graph is going all the way to what value that's to the left?
Negative infinity.
So you're gonna write negative infinity because it's always your smallest numbers to your largest numbers. So that's negative infinity is all the way to the furthest left. And then what's all the way to the furthest right?
Infinity.
Positive infinity. Now, I said specifically in interval notation, that's where the infinities are located. They're not located in set notation. And around your infinity should be what? Should it be a curly bracket?
Parentheses.
It should be a parentheses because curly brackets belong to what?
Set builder.
Set builder notation. The range, one of you guys, I highlighted it. One of you guys had said this when I said, what are words associated with range? One student said from the lowest to the highest. What's the lowest that this graph goes?
0.
It's 0. But does it ever actually equal 0? No, it does
No.
not. So because of that, you have to put a what around 0? A parenthesis. What's the highest it goes?
2.
Is 2 included?
Yes.
Sure
Yes.
is. So you put a what?
Bracket.
How do I write that notation? Go ahead.
It would be the bracket, then Y such that, and then I think the Y, then the E looking letter, and then the R with the 2 lines.
Very good. That's how you represent all real numbers. So whether it's domain or range, it's going to depend on whether or not it's an X or Y. Since it's domain, we will put X. Okay. So X, the set of X values says that X is the element of all real numbers. That's how you write that in set notation. Okay. But infinities, parentheses, brackets, they go with interval notation. You cannot mix them like this. You can mix parentheses and brackets, but you can't mix curly brackets with parentheses. Here, both of these are going to be in set notation. Both of these are going to be in set notation. In set notation, remember, you're dealing with your inequalities, no infinities, no unions. If you have multiple pieces in your domain or multiple pieces in your range, you separate them how? With a comma. So for your domain, let's take a look. From the furthest left, it's defined all the way from negative infinity all the way up until what value?
-2.
But then it picks up and it continues until what value? And then it continues after that value until?
Positive infinity.
So it includes every X value except what values? -2 and +2. So you could have set the set of X values such that X does not equal -2 and X does not equal +2. Why? Because in set notation, it includes all real numbers until you give it a restriction. X is greater than 3. X cannot equal -2, X cannot equal +2. Otherwise, it's all real numbers except those respective values. Now, some of you guys, question?
I thought the parabola on the bottom, I thought it was hitting -2 and +2.
Not with these dotted lines. These dotted lines, this is how you indicate an asymptote. So whenever you see these like dotted lines or you see the graph getting really close to something, it's unless you actually visually see it crossing, then it's assumed that there's an asymptote if there isn't a dotted line already there. Now, some of you guys wrote it like x was less than -2 to indicate this part, because yes, that is true. This would represent x is less than -2. To represent the part that's in between -2 and 2, you could have said -2 less than x less than 2. To represent the part that's greater than 2, you could have said x is greater than 2. You could have also written the domain like what you see in the red. That's a little bit more than just saying does not equal +2 or -2.
For the red one, you would have to write all of those sections for it to be correct.
Exactly, yes. Because you don't want to leave out any part of the domain. That would also have been the same thing if you were writing in interval notation. You would have to include all 3 parts if you were writing in an interval notation. Your range, how low to how high? What's the lowest the graph goes?
Negative infinity,
Until
positive infinity.
there's that space there. You have a hump all the way up until this actually is supposed to be -1. So technically, to represent this green part here, I need to say everything that is
Not equal to -1. I mean, I don't know.
less than or equal to -1, because -1 is included and it's everything that's below -1. So you would say y is less than or equal to -1 to indicate that bottom part. Of course, I need the rest of the goods. Now there's a space between -1 and 0 that there's nothing, there's no function in between there. But it picks up after 0 and goes until what? Positive infinity on both sides. So how do I represent everything that's above the x-axis? And that would be it in set notation. Essentially, if you're able to break it up and figure out, okay, what parts of the range are defined, an interval would have been easier for you. All you have to do is be able to convert that into set notation, okay? In interval, you would have had to do negative infinity to -1 bracket, union 0 to infinity. That is what the light blue is, what the green translates down into. Here, you would have had written 3 different parts if you ran an interval notation. Negative infinity to -2, union -2 to 2, union 2 to infinity. That is what the red essentially breaks down to be. That's what you would have had to do it if you wrote in the interval notation. You have to include every part of the domain in every part of the range. Do this one, whichever notation you feel more comfortable with. You want to try to test yourself, do one of each, okay? So you have the option, write the domain and range. All right, let's take a look, okay? Let's take a look here. We got both for this one, okay? The domain, the furthest left it goes is negative infinity. The furthest right it goes is positive infinity. Very good. The range is from -2 to infinity. There's a parentheses around the -2 because it's not included. There's an asymptote there. And then we have the range. It's one thing that's kind of, not the range. We have it in set notations. It's one thing that we need to fix about the domain. What do we need to fix about the domain? We're missing an extra x after that vertical bar, okay? Missing an x after the vertical bar, but here, it will be the set of x values since the x is the element of all real numbers. I know you guys can't get that symbol, so E is just fine. This is also the range in set notation, so very good. Very good, very good. They want to share. All right, so here we go. Moving forward, function notation, okay? Remember, IB has these 2 different ways they can represent function. Remember, f of x, that's your most common one. Usually the function's what follows afterwards. but this arrow notation is also the exact same thing as f of x equals, okay? So don't let that type of notation throw you off. A mapping diagram is another way that they could represent a function. It's definitely used to represent all types of different mathematical models: linear, quadratic, exponential, sinusoidal. The first bubble represents your x values or your domain. The second bubble represents your range values or your y's. The one thing that you need to be very careful of with the mapping diagram is that wherever the arrows are, that's indicative of the points that are on this particular function. So you have 2, 12, 6, 16, 7, 17, and 9, 19 are the points in this mapping diagram. Now they may give you a mapping diagram that may be, there's something in the domain, but there's not an arrow that points to a value in your range. Then that point is not a part of the ordered pairs of that function. Okay, so let's say that this arrow wasn't even there at all. That means 9, 19 wouldn't even be a point. It's just an additional value to throw you off. The arrows actually indicate the points, and then only those values will be a part of your domain, and then those values will only be a part of your range. So don't forget, when you are given a function, actual function, to find, each of these different values, what does g of 3 mean? The t equals 3, so you will plug in 3 for t, and you work it out. 3 squared is 9, 9 minus 4 is, this will be the exact answer. No need to actually type in the square root of 5 into your calculator, because then what you end up having is a decimal that you have to worry about rounding. And we know how y'all are about rounding, right? Here, what would I do to solve this one? Be very careful. -2 squared is 4 minus 4 is, what's the square root of 0? Always make sure that you do simplify though, okay? This one's an interesting one because in your calculator, there's a difference between this as well as this. Order of operations is what your calculator follows. It's going to square 2, then make it negative. But if you actually square -2, that's where you get the positive. So be very careful of how you plug that in. Same thing here. 1 squared minus 4, what do you get? Can you say the square root of -3?
No.
No, it doesn't cancel out the negative. That just means that there's no real solution here. You guys only deal with real solutions in this class, okay? You guys only deal with real solutions. What do you have a variable? I replace the t with the r. R squared minus 4, the square root of that does not equal r minus 2. That is your final answer. You cannot take the square root of each individual piece because of that minus in between them. Remember, r squared minus 4 is the same thing as saying r minus 2 times r plus 2. And you can't take the square root of either of those. So that means that this is your final answer. Do not take the square root of each individual term. What about this one? I replace t with a 1 plus h, and then I'll have to remember to do what to that 1 plus h? FOIL. Don't forget, when you square a binomial, that's the same thing as saying I multiply it by itself twice. Can you guys work this one out, please, and tell me what my final answer is going to be? What's my final answer for this one?
The square root of 2h squared minus 3.
2h squared? H squared plus 2h minus 3. Remember, when we FOILed this, we end up getting 1 plus 2h plus h squared. That's what these two will FOIL out to be. And we won't be able to.
You can't combine them?
Because this one's the squared and this one's the h. And so they're not alike, so we have to keep them separate.
And
Right?
you can't take that further with the h squared and take the h out of the root.
No, we wouldn't be able to do that because the 3 doesn't have an h in common. Now, if the 3 did have an h, then yes, we could have factored out an h, but we wouldn't have been able to pull it all the way out of the radical. So this is as far as we would be able to go with this particular problem. You guys got one on your own of similar nature. This is the one that you guys are working on. You're doing this one on the pear deck. Direct your attention back to the board, okay? Considering there wasn't much work done on y'all's boards, I'm not gonna broadcast answers, so you just kind of see if you did well. For A, you had a value, which means you had to plug in 2 for x, for 0 for x, and -1/2 for x. So when you did that, what did you guys get for I? Anyone? -7/2. Okay, remember, whether the numerator is negative or the denominator is negative, the entire fraction is negative. When you plug in 0 for x, somebody online, what did you get?
-3/4.
Very good. When you plug in 0 for x, what are you finding on the actual, like what is that called when you plug in 0 for x, like on the graph?
Y-intercept.
Yes, when you plug in 0 for x, you are finding the y-intercept of that respective function. So the y-intercept of this function was -3/4. How do you find the x-intercept?
You plug in 0 for y.
Make your y 0, plug in 0 for y, okay? Using extra opportunities to review things that you guys should know. When you plug in -1/2, if you typed it into your calculator, I hope you were very careful on how you typed it in. What did you get for your answer? Fraction, please. -4/9. Some of you guys who did provide a decimal, remember you rounded 3 significant figures, okay? 3 significant figures. Now for part B, it's asking you to find a value of x such that g of x does not exist. In this particular function, when would it not exist in general?
When the
When
denominator
there's-
is 0.
When the denominator equals 0. Anytime you have a fraction, you cannot have 0 in your denominator. So what value of x makes it so that the function does not exist is wherever the denominator equals 0, and that's x equals 4. Very good. For C, you had to evaluate by plugging in x plus 2. Everywhere you saw an x and simplify. You can only go but so far with this once you distribute and combine like terms. So what's our final answer?
2x plus 7 over x minus 2.
And that's as far as we can go, because I can't factor anything out of the numerator, nothing out of the denominator to cancel anything between them. So that's the furthest that we could go. I can't cancel the x's either because x is only in common between one term out of the entire numerator and the entire denominator, so we can't cancel the x's. Now, let's say there was an x in common in the top, and I was able to factor out an x in the bottom or something, then yeah, but not here. Oh man, the last one. This one was different. It was asking you to find x when g of x is equal to -3. So how do I set it up to solve?
You plug in -3 for g of x.
Plug in -3 for g of x. I set it equal to -3. And this became an algebraic expression in which I needed to cross multiply or multiply by the denominator, distribute, and continue to solve. What did x equal once you actually solve for x?
9/5.
Remember, leave answers exact. Otherwise, you have to round to 3 significant figures. Okay. Oh, that's got 1.8? Okay, well that one was, you lucked out, but at 4/9, I know did not end, right? So, one more thing I want to point out before we move into linear functions and wrap it up for the day. is inverse functions. Inverse functions is what we talked about before we went into linear functions. And inverse functions are when you reflect over the line y equals x. Okay? That's when you switch your x's and your y's. That's what you would do to graph the inverse. You would take your points and switch x and y. That's also what you do if algebraically you wanted to figure out what your inverse function was. You just switch the numbers. The signs stay the same, but you just switch the numbers. Okay? So if I had a function, which was y equals 3x minus 4, and I wanted to find the inverse, I would switch x and y. And I would continue to solve for y. I'll divide both sides by 3. I don't know if you guys can see that. So then I would end up with x plus 4 over 3. That would be my inverse function. Do y'all remember the notation that went with inverses? F to the negative 1. Not to be confused with the derivative, which is just like a little apostrophe, but a negative 1 in the exponent indicated the inverse. Remember, on your inverse function, the domain of your inverse function is the range of your original. And the range of your inverse function is the domain of your original. Literally everything about the inverse function is switched. Literally everything is switched. Wanted to highlight that real quick. Let's say for this particular problem, we have 2 -7 halves. We had 0, -3/4. And then we had -1/2 and -4/9. Those are all the points on the original function. So then on our inverse, again, all we do is we just switch x and y, but we don't change the sign. So then -7 over 2, 2 would be on my inverse. -3/4, 0 would be on my inverse. -4/9, -1/2 would be on my inverse. The domain of the original is now the range of my inverse. The range of my original is now the domain of my inverse. And that looks like a reflection over the line y equals x. Doing inverse, not inverse, linear functions real quick. We already talked about this. Let's see who's paying attention. Online, how do I find the x-intercept of a linear function?
Plug in 0 for y.
Plug in 0 for y. How do I find the y-intercept of a linear function?
Plug in 0 for x.
Yes, and to be honest, that's for any function, not just linear, any function. All right, so real quick, find the x and y intercept of this linear function. This one right here. Which are the correct answers?
Oh, we were supposed to do that on the slide.
Yeah,
Oh, okay.
which would be the correct answers here?
Both.
No,
The coordinate points.
the coordinate points. It's the coordinate points. Because x and y intercepts their actual points. Now if it asks you for the x value of the x-intercept or the y value of the y-intercept, then yes, x equals -1/2, x equals 1 will be fine, but since it asks you for the intercepts, remember they are points. So you need to make sure that you write them as such. Okay? Keep going with linear functions. Y equals mx plus c, where m is the gradient slope, c is the y-intercept. Yes, the y-intercept. Remember, m is the gradient, c is the y-intercept. M is the gradient, c is the y-intercept. Yes, that is old school mx plus c. Y'all know IB uses y equals mx plus c. So Gonna do this one together because we are running a little short on time, and I am gonna have to stop here and kind of pick up Thursday where we kind of left off. But it says the straight line L passes through the points A and B. Calculate the gradient of L. Okay, gradient, slope, old school slope. That formula is
y2 minus y1 over x2 minus x1.
and that formula is smacked up in your reference book. That's 8 minus 4 over 5 minus the negative 1. 8 minus 4 is 4. 5 minus the negative 1 turns into a plus. So then I get 6. That reduces down to be.
2/3.
You always want to make sure that you reduce. That is 2/3. Now you have to write the equation of L. The equation is in the form of y equals mx plus c. I can use either point A or B, plug in the y coordinates, plug in the gradient, plug in the x, so that I can find my c. Then I can write it into gradient intercept form. This becomes 10/3. So then c is going to equal 8 minus 10/3. 8 minus 10/3, I believe, is 14/3. Can I get confirmation? So then my equation would be 2/3 x plus 14/3. If it asked you to write a line, the equation of a line that was parallel, parallel lines have what? The exact same slope. So parallel lines have the exact same slope. But what if it asked you for a perpendicular line? So then what would the slope be?
-3 over 2.
Yep, and then I would use those slopes instead of 2/3 to find the equation of the line if it asked for a parallel or perpendicular one. Now it also says that the line passes through the point 8y. Find the value of y. Well, if it passes through a point, that means that when x is 8, y is what I'm looking for on the function. So then I plug in 8 to find that the corresponding y coordinate is 30 over 3, which equals what? What's 30 divided by 3? 10. So y is equal to 10. Going to use this opportunity, since this is going to be the last problem that we do. If it asks us to write this equation in standard form, which is ax plus by plus d equals 0. How would I take my equation that's in gradient intercept form to standard form?
It would be 2/3 x plus 1y plus 14 over 3.
Not plus y, but minus y, because I'll have to subtract it over.
Oh, yeah.
But not only that, I cannot have any fractions. So how do I get rid of the fraction? Say again. Multiply by 3, the entire equation. That's how I can get whole numbers. Because a lot of times they'll say A, B, and D are integers. So you multiply by whatever the denominator is to get rid of them. So then you'll have 0 equals 2x minus 3y plus 14. And now it's in standard form or general form. I can't remember the notation I used back in the day, but it's either standard or general. Correct. You can have negative numbers, but you cannot have fractions. Okay? That's linear equation. That's where we'll stop for today. But to recap, y equals mx plus c, old school slope. You've been doing this since algebra 1. Functions, domain and range, your inputs, your outputs, how far left, how far right, how low, how high. Interval versus set. inverse notation, function notation. Please make sure that you haven't forgotten anything.